Welcome back. In this lecture, we're going to talk about declaration and assignment. So we talked about the 5 things all programming languages need to know, and this covers the first 2, declaration of variables and assignment of values to those variables. So what are you going to know by the end of this? How to declare variables and attributes in a program, how to assign values to them, and what the computer's doing when you do these things. So here's a reminder, the 5 parts of computation: declare, assign, select portions of code, repeat portions of code, and provide input and output. We're going to cover the first 2, declaration and assignment. When you're declaring a variable, you're introducing the variable into the program. You're telling the computer that you want to use these things. When you're assigning values, you're actually storing values in memory locations. So, declaration. Telling the program you're going to use a variable. What you're really doing is telling the program to set aside some memory space that it needs to store values later on. Java requires that you provide 2 things in a declaration. One is the name of the value, and one is the type of data that the value is going to have, and we'll talk about data types in a little bit. Languages do vary. Some do not require separate declarations. Some languages just let you start using variables without declaring them separately. Java is not one of them. It's pretty straightforward. Basically, you give the data type followed by the variable name. In Java, we use descriptive names. By that I mean don't just call something, like don't call radius R, call it radius. And if it's radius of the lead pipe, you might want to call it radius of the lead pipe to distinguish it from radius of the copper pipe. So the names can get pretty long. Most of the editing tools that you deal with help you and will autocomplete, so you don't have to worry about typing all these long names. So, some examples. Again, most languages, all you do, you list the data type followed by the name you want. And fortunately, most languages have settled on the same code for the different kinds of data types. So, for example, you want to track how many number of games some player has won in a game. The number of games that you win is going to be an integer value, 0, 1, 2, 3, 4. You never win 1.5 games. You rarely win 1.5 games, I should say. So we would use an integer for that. And so int is short for integer, and it would be int number games won. That's a fairly descriptive name. Radius of a circle, int radius. Keep track of the number of fish in a tank, int number fish. Now notice the number of fish in a tank is also intrinsically an integer value. 0 fish, 1 fish, 2 fish, red fish, blue fish. Radius actually isn't, but I'm using it here as an example. How does that look in Notepad? Not too surprising. Int number games won, int radius, int number fish. I have no idea what that program would be doing. All right, so let's talk about those data types for a minute. Everything in the computer is just 1s and 0s, so the computer has no clue as to whether a sequence of 1s and 0s is supposed to be a letter of the alphabet, or a number, an integer value, a non-integer value, or some other form of data. So you have to tell it. And that's what declaration is about. You say, hey, not only is this a variable, radius, but it's an integer. So whenever you store it like an integer. Whenever you retrieve it and interpret it like an integer. Whenever you do an operation on it, like addition, do it like an integer. So the basic data types, we call these primitive data types, supported directly by a language. Int for integer values. Oddly enough, double for non-integer numeric values. So if you needed to do 73.567, you would use double. The value of pi, double. Most fractions, double. CHAR, often pronounced char, is actually for a single character or a keystroke. You know, we say character and everybody thinks A, B, C, D, but what about 0, 1, 2, 3, 4? Also can be treated as a char. What about a comma or a quotation mark? Think about any single keystroke on your keyboard. That's going to be a char. Then we have a string, which is a sequence of chars. So like when you put in your first name, my name Keith, that would be a string. If I did Keith A. Garfield, it would be a string, and then the A only has one letter, so I would probably use a char for that, and then the Garfield would be another string. And then Boolean, which is probably new to a lot of people taking the camp, is used for logic values, true-false values. And we use Booleans primarily to determine when we should do some things. If something is true, do something. If something is false, do something. So those are the basic primitive types that we'll deal with in the camp. Okay, how do we assign values to these things? Once we've declared them, how do we assign values? Really simple. You can assign constant values, like x equals 10. 10 is a constant. You can assign the values from other variables, x equals y. In other words, whatever value y has, whatever value is stored in the memory location that we're calling y, a copy of that is now stored in the memory location that we're calling x. You can do formulas, 2 times y plus 12. We use the star for multiplication. Most languages use the / for division, the plus sign for plus, and the hyphen for minus. If you need to show precedence, you use parentheses just like you learned in your algebra class. And then we can do, other formulas. Area equals length times width. Notice these are descriptive names. That means go to the place where length is, whatever's in memory there, get that value. Go to the place where width is, whatever's in memory, get that value. Multiply those two values together, store the result in the memory location we're calling area. How does it look in Notepad? Just like that. Notice there's a semicolon at the end of each of these lines of code. Java requires a semicolon at the end of each line of code. Many languages do. Some don't, many do. Java does. Okay, now let's walk through what it looks like in the memory. What's happening in memory? Well, let's see. First, we declare the variables. So here, lines 1, 2, and 3 are declaring 3 variables, x, y, and z. And what we're telling the computer to do is set up 3 separate memory locations that can hold integer values. And one of them is associated with the name x, 1y, and 1z. These are lousy names, by the way, but good for good for examples. The memory locations are blank at this point. Then we say line 5, x equals 10. What we're doing is we're putting the value of 10 in that memory location that we're calling x. We do the next line, line 7, y equals x. Oh, okay. Okay, so that's y equals x says go to the memory location called x, take whatever value is there, and put a copy of that value in the memory location that we're calling y. So now we have a 10 in the x location and a 10 in the y location. Now when we execute the next line, x equals 15, it just replaces that 10 in the x location with a 15. So notice now we have a 15 in the x location, a 10 in the y location. And then lastly, we say 3 times x minus y. Again, we'll go to the x location, grab that 15, multiply it by 3, go to the y location, grab that 10, and so we get 3 times 15 minus 10, which is 35. Place that result in the memory location that we're associating with z, so that we get the 35 in there. It can be important to remember these memory operations because when you think through what your code is doing, you want to be aware that you are supplying instructions to the computer to modify these memory locations, and you want to keep track in your head as to really what you're doing. What are you asking the computer to do? If you don't have a good mental model of what's happening in the computer, you can make some code that looks good and acts horribly. I'm not going to worry too much about this slide because we'll get this through the examples, but our naming conventions are that class names, remember, in the object-oriented world, we have classes, which are categories of things. Class names start with a capital letter. Attributes and variables start with a lowercase letter. Since they're long, we tend, like X location, Y location, max speed, we tend to capitalize the beginning of each word inside the variable name. It just makes it easier to read. Constant values, all caps. So pi is a real honest-to-gosh constant value inside of Java, and it's PI, capital PI. So these are conventions, which means your code will run even if you don't follow them, but basically people won't hire you because they don't think you know what you're doing. We'll get into these visibility modifiers in a little bit later. You can actually say, hey, this is something that's private, this is something that's public. Private means that nobody outside the class can see it. Public means others can. We'll talk more about that when we talk more in detail about classes and objects. And then the use of brackets. You're going to see a lot of curly brackets here. Curly brackets are always bounding blocks of programs. Parentheses are always used for inputs to methods or functions, and square brackets are used for arrays. We'll cover those later in the camp. So, summary. Java says that you have to declare all your variables. You have to provide the name and the type. The data types that you're going to work with tend to be integers, doubles. We'll do a little bit with chars and strings, and a little bit with booleans. The stuff we'll do with booleans will come up more in when we start to talk about selection and repetition. Later on, we'll talk about making more complex data types by taking the primitive ones and combining them.